Hello friends, so in this video I will try to give you some intuition or a very depth knowledge in this particular question. Okay, you can visualize this question after this video. Okay, so in this question E is given as E is vector is basically E naught of x component plus y component plus 2j z component and e to the power minus j omega t minus kx plus ky. Okay, and if you consider the z part, that is equals to basically 0 into z. Okay, so this is basically your electric field. Now we know we can write this as E is basically E naught x cap plus y cap plus 2j z cap e to the power minus j omega t minus of kx plus minus k of y. Okay, so in this case the direction of electric field or not direction, the direction of wave propagation is not in x, y or z direction. It is going in a specific direction which is not x or not y and not z direction. Okay, so in that case we can write this expression as general expression, that is E naught x cap plus y cap plus 2j z cap. So we can write the general general expression for this part as omega t minus k into r. Okay, where it will be k vector into r vector. Okay, k vector dot r vector. Okay, where r vector is basically the position vector, where you can write this as x into x cap plus y into y cap plus z into z cap. Okay, and k is a propagation vector and its direction is in the direction of wave propagation. Now if you consider the simple case, for example the wave is going in z direction. Okay, and the power is flowing in the z direction, means in the direction of wave, electromagnetic wave is z direction. In that case your k will be simply your some beta into z cap. Okay, so in that case your k vector dot r vector, it will be how much? It will be simply beta z. Okay, then you can write the expression as E naught some vector component, that is the direction of resultant direction of E naught. Then you can write e to the power minus j omega t minus k vector dot r vector, and this is basically your E naught within bracket some vector component minus j omega t minus beta z. Okay, so this particular expression is a general expression. Okay, specifically for this for the direction of wave propagation. Okay, similarly you can also write the general expression for direction of electric field, that is you can just remove this part and you can write it as say a x cap plus b y cap plus say c z cap. Okay, and a b c, it could be a constant, or maybe say e to the power j pi by 2 to include some phase. Okay, means a b and c, this could be these are the could be any constant or any complex number. Okay, okay, now let us consider our case. So in our case you can write for example say e vector as a x cap plus b y cap plus c z cap. So in our case it is only a is 1, so x cap plus b is 1, y cap plus it is j, means e to the power j pi by 2 is and z cap. Okay, so just write, and the j is basically equals to e to the power j pi by 2. Okay, and from here this expression we have basically your k vector dot r vector is basically your kx minus ky. Okay, and where you know r is the position vector, so you can write k vector as what, your k into x cap minus k into y cap. Okay, then only you can verify this as this way, that is k vector dot r vector is k into x cap minus k into y cap dot x into x cap, y into y cap, so plus z into z cap, and so it will be kx, then dot product with x and y will be 0, and similarly x and z is 0. Then the next finite quantity or non-zero quantity will be minus ky. Okay, so this is how you can verify. So this is our propagation vector. Okay, now if you have studied the electromagnetic theory, then you know that the for uniform plane wave, the direction of wave propagation is or direction of electric field and magnetic field is perpendicular to the direction of wave propagation, and more precisely the electric field, magnetic field and the direction of wave propagation are mutually orthogonal to each other. Okay, so in our case k is the direction of wave propagation, and the direction of k is the direction of wave propagation, and E is the direction of electric field, direction of E is the direction of electric field. So if you take the dot product between two, it must be 0. Okay, then you can say that this particular electromagnetic wave is a uniform plane wave. Okay, so what is our k? K is basically your k into x cap minus k into y cap. Okay, and we have E over here, so you can write that dot E is value is x cap plus y cap plus jz cap, sorry 2 is there, so here it will be 2. Okay, so now if you take the dot product, so this is basically your k, and then 0 0 and 0 and then minus k. Okay, so this is basically equals to 0. Now you can say that this particular electromagnetic field, electromagnetic wave represented by this electric field is a uniform plane wave. Okay, now we have to identify the state of polarization. To identify the state of polarization, let us try to draw the electric fields component in this particular for this particular electric field. Okay, E. Right, so for x component we have magnitude of E naught, so you can draw like this way. This is basically your E naught, right? This is basically your E naught in the direction of x. Okay, and then we have similarly for y cap direction, the magnitude is y naught, E naught. Okay, so it will be like this, same length. Okay, so it will be E naught, and then in the z direction its magnitude is 2 E naught. Okay, so it will be double, right? Double, the length is double, and so this is basically 2 E naught, but there is a factor j. Okay, and we know for j is basically e to the power j pi by 2. Okay, now what is the physical significance of this j? Okay, you can see the phase of x component and the y component is same. Okay, and they are 0. So this, suppose if you first consider the x component, they are oscillating, it means x component and your y component oscillating with same phase, right? They are oscillating with same phase. When the x component is maximum, at the same time the y component is maximum. Okay, but for the z component there is a pi by 2 phase shift, means when x and y component are maximum, in that case the z component will be 0. Okay, z component will be here. Okay, means when say x component is over here and z component y component is over here, at that time the z component is over here. Okay, so this is the meaning of your meaning of j. Okay, in this case. Now at this point let us also plot the direction of wave propagation in this system, in this coordinate system. So you can see that the direction of k is basically here it is k x cap minus k y cap. Okay, so you can plot this over here. So k x cap means say this particular, this length is k. Okay, this length is k, and so it will be k x cap and minus k y cap, so same length. Okay, this length is k, then the vector will be the resultant of these two. So this is the direction of wave propagation, the k. Okay, now let us come back to the direction of electric field. So we have the x component, this is x component, and this is y component, and we have also the z component, right? Now the resultant of x and y component will be, so if you can draw, so the resultant will be this one. Okay, and as the length that is on the x-axis and the y-axis are same, that is E0, so this particular length, the resultant vector, the length will be resultant of x and y component, it will be your simply root 2 into E0, right? Simple Pythagoras law, if you apply you will get root 2 into E0. Okay, and you can easily verify this angle is 45 degree because the two lengths are same. Okay, because if it is E0 then the resultant vector is root 2 E0 and this is angle is 45 degree. You can easily verify. Now this particular resultant vector is on xy plane, and the z vector, the component means this particular component, it is on the z axis. Okay, so this particular angle is basically your 90 degree. Okay, and this angle is also 90 degree because your k vector also in the xy plane, and at the same time if you consider this propagation vector, so x component and y component are same, so for this propagation vector also this angle is 90 degree and this angle is 45 degree. Okay, so what is the angle between this propagation vector and this resultant vector, electric field vector on the xy plane? This is also 90 degree because this is here, it is 45 degree, it is 45 degree, total 90 degree. Means I am trying to show you that this two component is perpendicular to the propagation vector, and this two component of the electric field component which will create polarization. Now you can see that this two component of electric field, that is this resultant component and this component on the z axis, has different magnitude. Okay, this has a magnitude of 2 E0 and it has root 2 E0. Okay, and what is the phase difference between them? I have already told you that the phase difference between x and z component is 90 degree and y and z component is also 90 degree because of this particular j in the expression. Okay, that means when x and y are maximum, in that case z is minimum, and when x and y are minimum, in that case x is z is maximum. Okay, and as this particular vector is the resultant of this x and y component, then we can say that the phase difference between this vector and the vector on the z direction is also be 90 degree. Okay, because of this particular j. Don't confuse with this particular 90 degree. Okay, this is not the phase difference between these two components. This is the angle difference of this particular axis and this particular vector. Okay, I am talking about the phase difference between this vector on the z axis and the vector of resultant of this x and y, that is this vector. Okay, so amplitudes are different and phase difference is 90 degree, so it must be a elliptically polarized wave. Okay, if you want to see little bit more, you can write the x and the resultant vector of this two component, that is this vector, and this is the resultant electric field, ultimate electric field, and which is elliptically rotating. Okay, this is how it is propagating. Okay, so this is how you can visualize this particular field, and I will also show you how you can directly or very quickly answer this particular question, and hope you have enjoyed this particular video. Thank you very much.